Recording in progress.
Okay, so that's what FOIL does. Basically, it just is the distributive property. So factoring is just working our way back to where it looks like we have something like x plus something and x minus something. So let's see how this would actually work. So if I want to look at this one here, so solve by factoring the first one. So you notice that in this top one here, there is something common to both of these. So I can factor out an x from both terms. So this would look like here, I have an x factored out. And what's the first piece? If I take out just one x from x squared, I'm left with another x, because x times x gives me x squared. And if I take out an x from minus 3x, I'm just left with minus 3. So, and this is equal to 0, right? So now the only way for the product of two things to be equal to 0 is either the first piece, so either, so let's say this implies either x equals 0, so either that first piece equals 0, or this second term is 0, or x minus 3 equals 0. And this would imply that x is what? If x minus 3 equals 0, then x equals what? 3, right? So then the two solutions to this one are equals 0. So that one is a little bit easier than the actual one up here at the top. So all you did was first figure out what the factor you could take out was. In this case, it was just x. So then we factor out an x from each of the terms. And then since we have the product of two terms is equal to 0, either the first term is 0 or the second term is 0, and you can solve each of those for the corresponding solution for x. Now the next one on here is actually where you actually have to factor. So how you do this is as follows. So we want to look at, it looks something like this. So we want x plus something here, and x minus something here. And the only reason, or let's say you can, oh, x plus here equals 0. So what we're trying to do is fill in two blanks there. So what we have to think of is first, what are the factors of the negative 30 or just 30? In this case, you can say negative 30. It's easy that way. And then whenever I do the product of those two numbers, which of those gives me a positive 1? So let's list out the factors of negative 30. So these can be positive or negative, right? Because you can multiply them together. So there's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6 plus or minus 10 plus or minus 15 plus or minus 30. So we want to look for a pair within this set of factors that multiplies together to give you minus 30, but adds together to give you positive 1. So you're looking for factors that are basically a distance of kind of 1 apart. So does anyone see 2 in there? That would make sense that whenever you multiply them together, you get minus 30. But when you add them together, you get positive 1. Yeah, 6 and negative 5 is correct. So that means we're going to have an x plus 6 here, and then an x plus negative 5. Or you could just say here x minus 5. So that's what factoring does. It goes in the reverse direction. Because here, look, if you multiply the first 2 terms together, that gives you x squared. If I multiply this times the outer term here, I get minus 5x. Then plus 6x gives me a positive x. And then 6 times minus 5 gives me the minus 30. Does everyone see that there? So now, same thing we did earlier. Either the first term is 0 or the second term is 0. So either x plus 6 equals 0. And this would imply that x is what? X is what in this case? If x plus 6 equals 0, then x is negative 6, correct? And if, so either this first term is 0 or x minus 5 equals 0. And if x minus 5 equals 0, then what is x? Someone besides Journey. 5, correct. X is 5. So in this case, the solutions are, so using these two, the solutions are x equals minus 6 and 5. That was a bad minus 6. So in this check step down here, what does it do? It just says plug in each of the values of x into the top thing up there. Let's see if it works. So what I'm going to do, plug in 6 for x and then 5 for x into the original equation. So this would look like minus 6 squared plus, or not in this case, it'd be minus 6 because plus minus 6 is minus 6 and then minus 30. So let's do it that. So this ends up being 36 minus 6 minus 30, which just ends up being 0, right? So that first one works when we have positives or negative 6. Now let's do when we have positive 5. So 5 squared minus, or not 5 squared, minus, but 5 squared plus 5, because in this case we had a positive 5, so that plus sign doesn't change, and then minus 30. So 25 plus 5 minus 30. 25 plus 5 is 30. Minus 30 is 0. Everyone okay with that? All we're doing is checking that our answer was correct on that one. If you wanted to check the first one, you would have done the same thing. Just plug in x is 0 into the original equation, and x is 3 into the original equation. So if you notice something about these first two questions, something they have in common, is the coefficient in front of the x squared. What is the coefficient in front of the x squared for both part A and part B? What is the coefficient in front of x squared? Yeah, it's a 1, right? So it makes it simpler with those two. Now let's move on to part C, where there's not a 1, but there's a 2. So, does anyone know what type of number 2 is? It's a special type of number. Whenever you only have the corresponding factors of this number are the number itself in 1, what type of number is it called? Yeah, prime number is correct. So that means that the factors are going to look like this. So you're going to have 2x plus something, and you're going to have 2x, not 2x, just x plus something, right? So now this is the tricky piece here, because you are dealing with a 2 now. But first, we're going to start doing the same thing. What two numbers multiply together to give you minus 5? So minus 5 is also a prime number. So the factors minus 5 are just plus or minus 1 and plus or minus 5. So one of them is going to be positive, one's going to be negative. We just have to figure out which one. So look at this. In the middle, you have a negative 9x. So that means, how can I get a negative 9x? But multiply the two numbers together to get minus 5. So let's say this is spot 1 here. So this is spot 1, this is spot 2. What goes in spot 1? What do you think? Positive or negative 1 or positive or negative 5? So negative 5 goes somewhere, but it doesn't go in spot 1. It goes spot 2. Eliana, you're correct. Positive 1 goes here. Positive 1 goes in slot 1. Negative 5 goes in slot 2. Because let's write out, or let's show how it does this, or why. So let me erase this under here too. So this should say 2x plus 1, and then x minus 5 right here. So now, here, look, here comes the 2x times the x. That gives me a 2x squared. Then 2x times minus 5 gives me a minus 10x, plus 1x gives me a minus 9x, and then 1 times minus 5 gives me the minus 5. And now what we want to do is solve each of these pieces, right? Either the first piece is 0 or the second piece is 0. So either two x plus 1 equals 0, and this implies that x is what? If I solve that, you get what? Minus a half is correct, yeah? Minus a half. And if I solve the other one, so either that equals 0 or the second term is 0, x minus 5 is 0. And that implies that x is what? 5, right? So our solutions here are x is minus a half, and 5. So let's look at this question down here at the bottom. It says, how are these solutions related to the graph of y equals 2x squared minus 9x plus 5? I don't know if there's a typo here or not. I'm going to answer the question as is, and then I'll tell you how it would be correct. So do you think there's a relation between the solutions of this equation and the solutions to the equation that's below it? So if you notice here, this says 2x squared minus 9x minus 5. This one says 2x squared minus 9x plus 5. So in this case, the solutions aren't the same, so they aren't the same. But for the equation y equals 2x squared minus 9x minus 5, the solutions are the x-intercepts on the graph. So if we would have graphed any of these and looked at where does it cross the x-axis, you would find out that all these solutions match where it crosses the x-axis. So now the next piece here that we're going to talk about is the quadratic formula. So is everyone okay with that first page there? That was using factor. Okay, so this next piece here is the quadratic formula. So some of you may have seen this before in high school, some of you may not. But let's look at this. So it says the quadratic formula, the solution to the quadratic equation in standard form. So a quadratic equation in standard form looks like this, where you have a term that involves an x squared here, then a regular linear term, and then a constant, and equals 0. So that is what a quadratic in standard form looks like. And the solutions to this equation can be found by the following formula. So we have x equals, in the numerator, negative b plus or minus the square root of b squared minus 4ac. And then we divide that quantity by 2a. So whenever we do this, there are three possibilities that could happen. So the first one is, if the stuff underneath the square root is positive or greater than 0, there's two solutions. If it's equal to 0, if the stuff under the square root is equal to 0, there's only one solution. And if the stuff under the square root is less than 0, then there are no solutions. And we have two complex solutions that involve something called an imaginary number that we talk about on the bottom of the page. So let's look at how do we use this thing. All right. So it says solve using the quadratic formula, keep the answer exact. So what we want to do is first make it look like it's in standard form, where we have ax squared plus bx plus c equals 0. They don't have to be pluses for those b's and c's. That can be negatives as well, and there could also be a negative on a. So let's write it like this. We already have 5x squared, but we want to get it to look like then we have a term involving x, and then we have a constant. So then it would look like this, right? 5x squared. And then we want a term that involves x. So there's a positive 6x on this side. We want to subtract it over to the left side. So minus 6x. And then to get the 5 over, we subtract 5 over again as well. So that's the equation in standard form. So now I know what's A, what's B, and what's C. So here, this implies that A is what? A is, what do you think? 5. What's B? And what's C? Yeah. So A was 5. B was negative 6. C was negative 5. So now all we do is plug them into this quadratic equation up top. So let's do that. So then this says x equals, in the numerator we have negative b. So this would be negative 6 or positive 6 plus or minus the square root of b squared minus 4ac. So minus 6 squared minus 4 times 5 times minus 5, all under the square root. Then divide that by 2 times a, or 2 times 5. Now let's simplify under the square root and see what happens. So this is 6 plus or minus. Negative 6 squared is 36. So the square root of 36. And then 4 times 5 times minus 5 is minus 100. But we have a negative here already, so this becomes plus 100. And then we still have in the denominator, 2 times 5 is 10. So now to simplify even more under the square root, this is 6 plus or minus the square root of 130 6 divided by 10. Now, here we go. So you could technically simplify this. So let's do this. 136 has a perfect square that can be factored out of it. Does anyone know what that perfect square is? Not 14. Take the 1 off of 14. What do you have if you do that? So remember, the perfect squares are 1, 4, 9, 16, 25, 36, 49, 81 or 64, 81. You just keep going. Can any of those numbers go into 136? Anything. There's one number in there that goes into 136, and that's 4. So, and what do I multiply that by to get this? So, 136 is equal to 4 times 34. So, and we also know this, that the square root of A times B is just the square root of A times the square root of B. So this is what we use to simplify radicals sometimes, if there's a perfect square that can be factored out. So then using this idea, we have the square root of 136 is equal to the square root of 4 times the square root of 34. But the square root of 4 is 2, so this is 2 square root of 30. Everyone okay with that? Does that make sense to everyone? So now let's plug that in here. So this would be 6 plus or minus 2 square root of 34 divided by 10. Do you think that can be simplified any more than that? So here is a little fun fact. If these 3 numbers here in red, then I'm going to do this here, this here, and this here. If those 3 have a common factor, it can be divided out. So in this case, what's the common factor between 6, 2, and 10? 2, right? So then I can divide each of those pieces by 2. So if I do that, then we're left with this. So 6 divided by 2 gives me 3. So 3 plus or minus. This 2 goes away. I'm just 2 divided by 2 is just 1. So this is 3 plus or minus the square root of 34 divided by, if I take a 2 out of 10, then I have 5 of those. That's the final simplified form. 3 plus or minus the square root of 34 over 5. And there's two solutions right here, right? Whenever I take 3 minus the square root of 34 and I divide that by 5, that's one of the solutions. And when I take 3 plus the square root of 34 divided by 5, that's the other solution. So in this case, there were two real solutions because the thing b squared minus 4ac under the square root was strictly greater than 0. In this case, it was actually 136. So this is the exact answer. This is what the exact answer looks like. You still have the radical there because this radical cannot be further simplified. The square root of 34 cannot be simplified anymore, so just leave it as that. So these are your two solutions. If you want me to write them out, so this implies that x is 3 minus the square root of 34 over 5. Okay. And the other one is 3 plus the square root of 34 divided by 5. So those are your two solutions. So that one took a little bit, right? Let's move on to something next. What happens if the stuff under the square root up there was negative? Then we have to introduce something called imaginary numbers, and this was invented a while back. That way you could completely factor all binomials, so all x squared things. So it starts off by saying the square root of minus 1 and just letting it equal the imaginary number I. So right here, the square root of minus 1 is I. This is the whole basis of the imaginary numbers. And then the next piece here uses this idea that I talked about right here in red. Then it uses this piece here. Then the square root of negative a, let's write it out, is equal to the negative, or the square root of negative 1 times the square root of a. But again, remember, we just said the square root of minus 1 is I. So this is I square root of a. That's where it gets this second thing here. And then these complex numbers that we see that look like a plus bi and a minus bi, they come in pairs. So whenever you factor something like this, that we'll look at a second, complex numbers come in pairs. You have a plus bi and you have a minus bi. So this example here, example 3, where it says rewrite this, all I want you to do is use that property, the one that I just did in red a second ago, that the square root of negative a is I square root of a. That's all I want you to do. So let's try this. So it says rewrite 4 plus the square root of negative 36 over 2. So the only thing that's going to be simplified is the stuff under the radical. So this would be 4 plus, what's the square root of negative 36? What do you think? If you want to do, let's just write it as this piece first in red. This would be I times the square root of 6, right? So this would be 4 plus I square root of 36 divided by 2. But what is the square root of 36? So this would be 4, yeah, 6, right? So this is 4 plus 6I over 2. And then we can just divide the 2 through both of these to simplify it. This becomes 2 plus 3I. Dang it. Writing on an iPad's harder than you think. 2 plus 3I is the simplest it can get. So that one's not too bad because we already had a perfect square there. Is everyone okay with that? Are there any questions over that? Okay. Now, let's look at this equation here for an example 4. And it says solve the equation in the complex number system. So in this case, you get something that involves complex numbers, and it's actually not too bad. So let's go ahead and start with it. So here, let's identify what A, B, and C are. So what's A? A is 1. What is B? And what is C? Yes. So A was 1, B was negative 10, C was 29. So now I just want to plug them into the quadratic formulas. This would be x equals negative b. So it's negative already, so it's going to be 10 plus or minus the square root of minus 10 squared minus 4 times a, which is 1, times c, which is 29. That's all under the square roots. Then divide that by 2 times a, or 2 times 1. Now I want to simplify under the square root. So here we still have 10 plus or minus. Negative 10 squared is 100. Oops, let's not extend the square root yet. 100. And then minus 4 times 29 is 136. So this is 100 minus 136. That's under the square root divided by 2. But 100 minus 36 is what? Negative 36, right? So this is 10 plus or minus the square root of negative 36, and then divide this by 2. But what is the square root of negative 36 as an imaginary number? 6i, right? So this is 10 plus or minus 6i over 2. And then again, both of those, the 10 and the 6, are both divisible by 2, so we can divide it out. And we're left with 10 divided by 2 gives me 5. And then 6i divided by 2 gives me a 3i. So that implies that x is equal to 5 plus or minus 3i. So this means our solutions are x equals 5 minus 3i and 5 plus 3i. Those are our two solutions there. That one is a little bit more complicated, but it was actually nice because the stuff under the square root, when I took away the negative, was actually a perfect square. Are there any questions over that one there? So now let's move on to the square root method. So the square root method says if x squared is equal to d, then I can just take the square root of both sides, and we get x is equal to plus or minus the square root of d. So if we want to do that, then if x squared is equal to 25, then we have x is equal to plus or minus the square root of 25. And what is the square root of 25? 5, right? So this is x equals plus or minus 5. That one's easy. Now this next piece here, instead of just putting an x squared, it says, let's do x plus 3 squared is equal to 18. So then if I take the square root of both sides, then this says x plus 3 is equal to plus or minus the square root of 18. So then you can subtract 3 over, and this says x equals negative 3 plus or minus the square root of 18, right? Or you can write it like this with the radical simplified. This would be negative 3 plus or minus 3 square root of 2. 3 square root of 2 is just the simplified version of the square root of 18. Because of the square root of 18, remember 18 is just 9 times 2, so this can be factored into the square root of 9 times the square root of 2. And the square root of 9 is 3, so this is 3 square root of 2. Then the last one on this page, at least for the square root method, can be done by this. So if x squared is equal to minus 100, then x equals plus or minus the square root of minus 100. But what's the square root of minus 100? 10i is correct. So this is plus or minus 10i. Now, let's look at the next thing here. So solve using the quadratic formula. Be careful with negatives. So let's do this. So we know A is 7, B is minus 2, C is minus 5. Then plug it into the quadratic formula. Then x equals negative b, but here b is already negative, so it becomes positive. So this is positive 2 plus or minus the square root of b squared negative 2 squared minus 4 times a, which is 7, times minus 5, all under the square root, divided by 2 times a, which is 7. So now let's simplify the stuff under the square root. So this is 2 plus or minus the square root of 2 squared is 4. So those would be 4. And then 4 times 7 times minus 5 gives me a minus 140. But there's already a minus here, so it's plus 140. And then in the bottom, we have 2 times 7 is 14. So, but 4 plus 140 is 144. And what's the square root of 144? What is it? 12 is correct. So this is just 2 plus or minus 12 over 14. So if I end up solving this, this implies that x is equal to, so if I do 2 minus 12, then I get a minus 10 over 14. So that's the first one. But what if I do a 2 plus 12? If I plus 12, that gives me 14, and 14 over 14 is 1. So the two solutions are x is minus 10/14 and 1. And the last thing on here says rewrite the following as a complex number. So this would be, if I want to do that, 3 minus I square root of 49. But the square root of 49 is what? Square root of 49 is 7, right? So this is 3 minus 7i. And that's how you simplify that one. Are there any questions over any of that stuff on that section of notes there? Okay. So that was all for section A.6. Now let's go to the next thing, which is quadratic functions and inequalities, right? Let me check to make sure it's the right next one. No, the next one is solving radical equations. So we're going to go A10. So this one here. Okay, there. All right, so we're going to begin by defining something called the principal square root. So it says if a is a non-negative real number, the non-negative number b, for which b squared equals a, is the principal square root of a, and is denoted by b equals the square root of a. So it just says, for example, the principal square root of 16 is 4 because 4 is just the square root of 16. So this says that the principal square root of a number can but not be negative. So it says think that the square root of x does not think the square root of x does not equal -2. So -2 will never be a principal square root of a real number. So let's look at this example here. So it says determine whether the statement is true or false. So it says x equals -8 is a solution to the square root of x plus 12 equals x plus 6. So let's see what happens. Let's plug -8 into both sides. So if I plug -8 into x, then this here becomes the square root of -8 plus 12 is equal to -8 plus 6. So let's do this. On the left-hand side, we're left with the square root of 4, right? And on the right-hand side, we're left with -2. So, but remember, here it says the principal square root of something can't be negative. So, this implies that x equals -8 is not a solution because the principal square root can't be negative. Just think of it this way. When you take a square root of a number, you never get a negative number. You always get a positive number, right? So let's look at the next one here. It says solve the radical equation. So notice that we have a square root on the left-hand side. How do we get rid of a square root? You do what to both sides? If I want to get rid of this square root here, we square both sides, right? So let's square both sides of this. So this would look like 8x minus 24 equals, what's 8 squared? 64, right? So this says 8x minus 24 equals 64. Now we just want to solve for x. So add 24 to both sides. You're left with 8x equals 64 plus 24 is 88. Now if I divide by 8, then x is 11, right? Now let's check our answer. How do we do that? We just plug it back in, right? So let's do that. So we're going to do the square root of 8 times 11 minus 24. So 8 times 11 is 88. 88 minus 24 is 64. This is the square root of 64, and the square root of 64 is indeed 8. So this equation up here does work. It does make sense. So x is 11 is the correct answer. All right. So now let's go ahead and look at the next example. Is everyone okay with the first and the second example here? So you have to know that the principal square root can't be negative, because when you take the square root of a number, it's never negative. So let's look at number 3. It says solve the radical equation below. So the first step we're going to do is subtract 6 from both sides. So then it would start out looking like this. The square root of 4x plus 13 equals negative 5, right? I can stop right there because, remember, the principal square root can never be negative. So there's already going to be no solution to this. It's not going to work whenever I plug in a value for x. So, but let's see what happens if I try to do it. So if I want to try to go ahead and do this, I'm going to square both sides first. If I do that, I get 4x plus 13 is 25, right? And then I'll solve for x. Subtract 13 from both sides, I get 4x equals 12. And x equals 3, right? Dividing both sides by 4. But let's see what happens if I plug in that 3 back into the original equation up here. If I plug in 3 to this part here, and I simplify this part, let's see what happens. The part I just put in brackets. So I'm going to do the square root of 4 times 3 plus 13 all under the square root. And then I'm going to add 5 to that, or add 6, I mean. So under the square root, 4 times 3 is 12. 12 plus 13 is 25. So this is the square root of 25 plus 6, but the square root of 25 is 5. So this is 5 plus 6, which is 11. But what was it supposed to equal? Up here it said it was supposed to equal 1. And obviously, 11 does not equal 1. So therefore, x equals 3 is not a solution. In fact, there's no solution because the principal square root can't be negative. Everyone okay with that? Okay, let's move on to example 4. It says solve the radical equation, the square root of 48 minus 2x equals x. So we're going to start by, again, squaring both sides. So if we square both sides, we get 40x, 48 minus 2x equals x squared. Now we want to move stuff around and then try to factor. So this would be x squared If I want to move the 2x over, the minus 2x over, I add it over, so it's to be x squared plus 2x. And to move the positive 48 over, I subtract it. So minus 48, 0. Now I want to factor this thing. So I'm going to have an x plus something and an x minus something. So x plus something here, and x minus something here. Someone tell me what goes next to the plus and what goes next to the minus. What do you think? What two numbers multiply together to give you minus 48, but add together to give you positive 2? What do you think? Yeah, 8 and negative 6 are correct. 8 goes here, and then negative 6 goes there. So let's write this a little better here. X minus 6. So then I solve each of these pieces. So if x plus 8 equals 0, then x is what? X equals what? If I do x plus 8 equals 0, then x equals what? Negative 8. Yeah, that's the first one. And if I do x minus 6 equals 0, then the other one is x equals 6, right? But notice what are x's here. X is right here. So if I plug in minus 8 here, it doesn't make sense because a principal square root can't be negative. So a principal square root can't be negative. Which implies x is 6 is the only solution. So let's plug in 6 and see what happens. So if I do that, this is the square root of 40. Oops, that was awful. Let's restart that writing there. The square root of 48 minus 2 times 6. So this is 48 minus 12, or the square root of 36. And that does indeed equal 6. So we're good. So now we're going to go to one that's a little bit more complicated. So this says solve the radical equation that looks like this. X equals the square root of 13x minus 68 plus 2. What do you think we're going to do to both sides first? What do you think makes the most sense to do first to both sides? Subtract 2, right? So it's going to look like x minus 2 equals the square root of 13x minus 68. Now what do I do to both sides? To get rid of the square root, I want to square both sides, right? So this becomes So if I do x minus 2 squared, that's x minus 2 times x minus 2. So if I FOIL this out, this becomes x squared minus 2x minus 2x plus 4. Or, to simplify that, x squared minus 4x plus 4. So on the left-hand side, when I square it, I get x squared minus 4x plus 4. And on the right-hand side, I get 13x minus 68. And now I can move everything over to the left-hand side and factor it. So let's do that. So this is x squared still. To move over this 13x, I need to subtract it over to the other side. So this would be minus 17x. And to move over the negative 68, I need to add it over. So add 72. And then since I subtracted the 13x over to the left and added the 68 over, I'm left with 0 on the right. Now, what two factors, or two numbers in this case, multiply together to give me positive 72, but add to give me minus 17? What do you think? So here, yeah, negative 9 and negative 8 are correct. So we're going to have x minus 8 and x minus 9 are our two factors. Now solve both of these, right? And you get what? If I solve the first one, x minus 8 equals 0 implies that x is what? 8. And when I solve x minus 9 equals 0, it implies that x is what? 9, right? So either x is 8 or x is 9. And you can check those if you want, but I'm not going to do that. If you check them, you end up showing that they're both actually correct. What I'm going to do is finish off with this right here. So we talked about this before, that x to the 1/2 power is equivalent to the square root of x. So what this does here, so solve the radical equation. So what I want to do is first square both sides. If I square both sides, it's going to look like this in a second. Well, let's do this. So 15 minus x to the 1/2 times 15 minus x to the 1/2. Because if I have to square both sides, I'm going to have to multiply this by itself. So let's simplify this and see what happens. So 15 times 15 is 225. Then I have minus 15x to the 1/2 minus 15x to the 1/2, and then plus x to the 1/2 times x to the 1/2 is x to the 1, or x. So this actually gets simpler by just combining these two here. The minus 15x to the 1/2 and minus 16x to the 1/2 becomes 30x to the 1/2, or minus 30x to the 1/2. So when I square this left-hand side, I get x minus 75, right? But when I square the right-hand side, I got 225 minus 30 x to the half plus x, right? But now what can I do? I can cancel out the x from both sides, right? I can subtract off the x. This goes away. And I'm left with minus 75 equals 225 minus 30 x to the half. Now, let's subtract 225 from both sides. And if I do that, this becomes minus. So if I subtract 225 from both sides, I get minus 300 equals minus 30 x to the half. So now divide both sides by minus 30. I get 10 equals x to the half. But remember, x to the half is just the square root of x. So this says 10 equals the square root of x. And to get rid of that square root, I just square both sides, right? And I get x equals 10 squared is 100, right? And if you want to check it, let's do that real quick. So the square root of 100 minus 75, that's the left-hand side of the equation, is just the square root of 25, or 5. Now let's see what happens when I do the right-hand side. 15 minus 100 to the 1/2 is just 15 minus the square root of 100 is 10, so 15 minus 10 is 5, and it checks out. So what I'm going to leave y'all to do until next Tuesday, we should be in person next Tuesday, hopefully. I want you to finish this class activity here, and we will go over the solutions to these two next Tuesday. So just follow some procedures that were similar to what we have before, and we will talk about them on next Tuesday. All right, and we'll finish here for the day.